Hello, YouTubers. This is the second video where we continue to talk about, building Blazor applications in a very well-architected industrial way, in a way that makes it a lot easier for you to modularize your components in Blazor, be able to test drive each and every piece of your Blazor application without any issues. And like I said, the development on this project that I'm working on is a part of a big initiative I've started with a bunch of engineers about a couple of months ago, which I call the OSSS project, which is a project aimed to help financially disadvantaged students around the world to be able to benefit from the funds of schooling software systems, while these schools get to use the actual system that we developed particularly for free. So last time we talked about, a high-level architecture, right? We talked about, brokers and services and view services, and we said, this is basically your view pipeline, and this is your data pipeline, and they both meet each other on the component layer. And I want you to really burn that image in your memory, because what's basically happening is that everything around that plays within that pattern, and that pattern is what makes it a lot easier for you to know what to test, what to focus on, where your business logic is, where you need to look, especially with bigger projects, like especially if you have a project with some, 50, 60, 70 different components that you need to maintain and make sure they work properly together. The more strict you are with the principles that you're carrying and the architecture and patterns that you're carrying, the more easier it is for you to maintain the project. The idea is basically to be able to, take in any more changes or requirements, or do any refactoring or code rubs, without any issues. So let me start the OSSS project here. Let's see where we stopped. So here's the OSSS project. I can see here, I was showing you that there are pages and components and bases and all that kind of good stuff. So let's start again from the bottom, right? So we built brokers, and these brokers basically have, there's date time brokers. It's something that captures the current date time. We talked about the loggings, and the logging basically is going to help us, track any changes and whatnot. It makes it a lot easier for us to see what's going on. And then there's also the API broker, which is basically just a high-level API operations, right, before we actually start talking about any actual implementation regarding a particular endpoint. All right. So since we're talking about particular endpoints, let's go to our API project here, which is also called OSSS. And let's take a look at what endpoint we really want to work against, right? So I'm opening here my Visual Studio. There you go. And then here we go. So we have our OSSS. I hope I increased the font on Visual Studio a little bit for people who have been asking me, to increase the font so they can see what's going on. This is a ginormous project. It's an open source project. It has a lot of contributors in it from all over the world. You'll see acceptance tests, unit tests. I can promise you right now, if you go into this project, you haven't been already, the first thing you will learn something. You will learn something definitely. There's about 395. That's as far as I remember. I think if I pull latest for that project, I think they're going to be a lot more than that, as the good-hearted engineers, I like to call them, are continuing to contribute to the project and continuing to make sure there is a pure code, a lot more functionality, and all that kind of stuff. Anyway, the one thing I want to care about really is that there are controllers in here, and these controllers have some sort of, endpoints, and these endpoints will allow us to integrate with these endpoints once they're running, to be able to communicate with the API and actually add data and remove data and do all that kind of good stuff. So there's an endpoint here in particular under API/students. When you're looking at your students controller, the name of your controller, this annotation here basically means omit the controller piece from the name of this class, and then it becomes API/students, right? API/students. It basically omits, a part of the name of your class, so your class is not called API/students controller. It'll be just API/students. All right, and then there's this endpoint in here that we really care about, and this endpoint accepts a body of a student that has all of that information. Some user ID, identity number, first name, middle name, last name, birth date, and gender, and so many other things that are included in that model. What we're going to be starting to work on today is basically to integrate our API with that endpoint. But in order for that to work, I'm going to need my model here to work with. Now, it is true that you can share your models, across a Blazor application and a backend application, but it's not true that you will always need all the information that's in there, right? And a lot of people say, oh, let's just build a library or a NuGet library that has all our models, and let's just use that across multiple projects. That definitely works in some scenarios. I personally like to keep things loosely coupled, no dependency on anything. If I need that model, I'm going to use that model in its full extent. And if I don't need everything in this model, I probably just won't do that. So let's just go ahead and take that model, this entire model in here. See, I don't need the student semester courses and all that, so I really don't need that extra overhead of stuff in my model. I'm just gonna go here into my Blazor application under models, and then I'm gonna build in here a new model, a new folder. I'm gonna call it students, and under students, I'm gonna create student. So that's my student model right here. And then in my student model, I'm basically going to go and say, put in these properties. So I have all of these properties. I think the only thing that I'm missing here is gender, I think. So let's just fix that. Let's take a new line in here, and let's go fix the gender piece. Let's take iAuditable. So this is my student. Oh, I pasted two student classes inside of each other. That's not what we want to do. So let's take that guy out like this, and let's put that in here. And let's just go ahead and create the student gender piece, which is basically an enum, and it has a female, male, or other. Right? So you have this gender stuff, and then I'm gonna clean this up. I'm just gonna do Alt Enter and just add both like that. And now we want to basically use that. So instead of gender in here, I'm gonna call it student gender, like this. And now we can work with whatever we got. Let's just add some banners in here. Here you go. And all right. Right here, it's all good and dandy. Let's go ahead and build our API in a way that allows us to post student entity to a particular endpoint, right? So we're going to start from the brokers, and I want you to pay very close attention here, because this here is done. This is the core API piece. Now I'm building this broker piece, right? So this guy here is just an API that already exists. The folks that are working with me have already done that. Now we are working on this one. So the ones that are not done, I'm just going to keep them as a dark object, and the ones that are in progress, they're going to be yellow, and the ones that are done are going to be in green. So now we're moving on to the second piece in my system here, which are the brokers, right? Let's go ahead and build student brokers. So I have API broker in here and have iAPI broker. Let's go build the interface, which is, we're going to use partial interfaces in here. So API broker dot students. So this is a partial. Oh, let me fix that. Dot students.cs. So let's go here and say right click, new file. Right, and now you have interface API broker dot students dot cs. All right, so I have my student CS, which is a partial class that lives under a partial interface that lives under the existing iAPI broker. So we may as well call that guy partial. And then let's go in here and start thinking about, just like we did, like for those of you who are following my videos on my architecture, you'll remember that I always talk about brokers, services, and controllers. So just exactly the same way. If you look at the previous project, you will notice the exact same pattern that's going on in the brokers area. If you expand brokers, you'll see that iStorage broker, and then you have iStorage broker.students, which contain all the methods. Specifically, like the class itself is very targeted as a single responsibility towards all the CRUD operations for the student model. All right, so we have that part. Let's go in here and just do exactly the same thing. I'm just going to start with the stuff I need. I don't have to do everything. So let me clean that up real quick, and then I'm going to go in here and say value task. Value task is a lot faster than task. And then let's say student, and then in here post student async, which takes in a student model like this. Now, let me stop you here for a second. Let me explain something to you. Just like how the brokers and the API speak the storage language, you will notice on the API side, we go and say insert student async. Look at this, insert student async, just like the database. You say insert into database values 1, 2, 3. The brokers, when they're talking to an API, they speak the API language. The language that they're speaking. They don't say enroll or register or add student. They say post, because they're basically telling you we're actually a broker, like for a broker neighboring service. As soon as it touches that method, it's basically telling you, hey, this is the last point of contact, with our data before we send it off to another microservice. So be aware that this is the language that we're using for consistency and for really to invest in the beauty of our code, to make sure that it actually speaks. So you basically say post, delete, put, even if you're doing a particular operation like accepting a request, for instance, you'll be saying put, accept, request, async, and stuff like that. So all right, we have the interface in here. Let's move on to the implementation. So I'm just going to go in here and say API broker .students.cs. So this guy, see, it will nest right under, it nests right under the class, which is beautiful, because if I collapse everything like this, now this is an encapsulator of all the things that are related to your API broker. Instead of opening this guy and seeing like 50,000 lines of code for all the operations that you have on your system, or you try to tightly couple the operations and say, oh, there's post async, but there's each and every one, and let me just have 50 lines of constant URLs. We're just mainly focused on the one file and the one operations for a particular entity. So public partial class, because this is going to be partial, and then under this guy here, I'm going to go here and say partial, and then the implementation that I want to do is basically a public async value task of a student, and this guy will say post student async, and you're passing in your student object into your method like this. So this is pretty straightforward. Now in order for us to get that implemented, we already have the methods that we implemented on the base API. So we have in here the get async, we have the post async, we have all of these different methods. Let's go ahead and just take advantage of the post async. Obviously this library, this implementation is leveraging the RESTful Sense library, very, very open source, powerful library that I built with a couple of very smart engineers. It takes away the whole noise of, oh, I need to read async and serialize and deserialize my object. It also gives you very, very meaningful exceptions, like we're going to talk about in a second, when it comes to posting and communicating with an API, right? I'm gonna walk you through that in a little bit. All right, so you have post async. So let's just go ahead in here and say post student async. Here's a fat arrow because it's just going to be one function, and you can go and say await this dot post async, and I'm expecting a student. You can use the angle bracket if you want to, but because the object that you're passing in is carrying its own type, you won't need to. Like even if we put it like this and say, okay, here's my relative URL. Now I need a relative URL. So let's go ahead and build a private constant string relative URL, which is going to be API/students. I can now pass in that relative URL in here, and I can also pass the student as a content. You will notice Visual Studio is really smart. It's telling you don't need to have that guy in here, simply because since you passed in this guy, automatically, we know what type you're trying to pass in, since you are expecting, like RESTful Sense will give you two operations, right, for post. You can post one type and receive a completely different type. That's one thing you can do. Or you can post a type, an object of a particular type, and then expect back an object of the exact same type, like our case in here. So in here you could actually go and do control period, and it'll just simplify the post async for you, so it makes things a lot easier for you. Okay, so we built post student async. Now I can pass in a student and then continue my operations. So that basically finalizes this piece right here. That means I built an endpoint that allows me to post a student to an API, right? So let's just go ahead and commit that for the purity of code. Let's just go here and say implement implement API broker to post student async, right? Along with that, added student model, added student gender enum, and what else did we do? I think that's pretty much it. The API broker and all that kind of stuff. Great. So for the purity of our code, this is one piece. It's revertible. It's a lot easier to go back and change it if we find it not in good shape. Okay, we have this guy. Now we need to do a little bit of cleanup. So let's just clean these things up. Let's add a banner. Right. And here's a banner. And you can also go on top here and say analyze code and then run profile, or you can click, like my friend Roberto will tell you, if you click on this little, icon down here, it'll just clean up the solution for you. What does that really do? Like, let's say I have something dirty like this, like I have a space between, post student async and the parentheses. If I click that, it'll fix it for you. I'll just keep your application indented properly, so it's a lot easier. It doesn't take much of your cognitive resources to understand what's actually going on. All right, so there's a code drop. Let me commit that and just say code drop. Code drop, just a quick code drop. Here we go. All right, we have that stuff. Now let's move on to the next thing. The next thing here is to build a service method, and this service method is responsible for, persisting a student object through the API. And we probably gonna just limit this video to just talk about the student service, because it's gonna take a little bit of time because it's test driven. It's probably written, write it once and do it everywhere. But let's just move on and see what that would look like. So in here, let's go back to our design as we go, and now we're starting to work on this service right here. So I'm going to mark this as orange or yellow, I think. So that means this guy is in progress, right? Let's go on and build a student service. So in the services area, I'm just going to create a new folder in here, and I'm going to call this folder students, like after the model. And then I'm going to go and build an interface, and I'm going to call this interface iStudentService. All right, so that's my iStudentService. This is the interface that I have to work with our brokers, to communicate with our brokers. Let's go ahead and add some banners in here. And what I expect to have is basically value task, student. Now the language is going to change a little bit, because the language here is basically not insert, not post student anymore. It's something more specific to the business. So let's call this, I don't know, what did we call it? Did we call it register or enroll student on the API side? Let's steal this from the other side. This is services, students, register student async. Yeah, let's do that. Why not? So register student async, and it's taken in a student like this, and it's going to process that student and post it to the API. But this time, because we are in the services layer, that means there's some business logic. And because there's some business logic, we want to make sure that our business logic is test driven and that it's properly written. So let's go and add in the other class in here, which is student service. .cs, and student service implements iStudentService, and let's go ahead and do control period. It'll give me an unimplemented exception. That's fine. And then let's just, before we write any implementation, let's just build in all the dependencies that we need in here. So what are the dependencies we need? As you may have guessed, we need the API broker, right? So I'm going to say iAPI broker, and this is an interface because it's a dependency that I can mock and pretend that it's behaving in any other way. I don't want to call the API every time I run a unit test, right? That would cause a lot of trouble. It would actually post real data, and that wouldn't be a unit test at all. So here's my API broker. And then along with that, I probably want a logging broker. And the logging broker here responsibility is to alert me, to log events, to alert me if there's anything wrong that's going on with the world, right? So if I'm posting a student and I keep getting errors on the client side, I need these events to occur, like a critical and error events to happen, so you are aware of what's actually going on with the system. Great. Now let's build the constructor. And then that constructor will taking these exact dependencies as input parameters. So I API broker, and this is I logging broker. Like this, it's great. So this dot API broker equals API broker, and this dot logging broker equal logging broker. Perfect. So you have that stuff. That's great. Now my service is ready with this state, the state that it's in. My service is ready to be test driven, right? For me to write some tests and make sure that these tests actually fulfill the business logic that I'm trying to work with. So let's go ahead and write some tests in my service. Let's just go here and say services. And under services, the exact same structures. I'm going to say students. Let me hide the camera here so you guys can see. So under here, there's students. And under students, let me delete that delete me file. I don't need it anymore. And then under students, let's just go ahead and create a new test class. And that test class will be student service tests.cs. So here's this guy, which is great. Now let's add a little bit of copywriting in here. And I'm just going to go and say public. And let's set up our test base class. This is a test base class that I really care about. Let's go ahead and set up that test base class. So I'm going to go here and say, private, read only, everything that's a dependency for me, I'm going to add it as a mock. So I mocked I API broker. So this is API broker mock. And then also I have a private, read only mock I logging broker. Logging broker mock, and then let's just set that up. These are the mocks because these are the things that I'm going to pass in as dependency for my service implementation. Remember how when we went back here and we said, we have a constructor, and this constructor is going to take these things as dependencies. We're going to do exactly that. What we're going to do is that we're going to pass these as dependencies, but the difference here is that these dependencies are actually mocks. They're not the real dependencies, and then we're going to control their behaviors as we go. Just a normal test-driven approach, and we're going to talk a little bit about it as we go. So in here, I'm just going to go and say this dot API broker mock equal new. Visual Studio is so awesome. It's completing things for me. Logging broker new, and here's another mock, and then we need the actual service itself that we're working against. So private read only I student service, so that's my student service, and then my student service here, I'm going to go and say student service equals new student service. Let's see if Visual Studio can figure that one out. Student service like this, and this student service will basically take those parameters that we're talking about. So the first parameter here is API broker, which will be API broker mock.object. Don't forget to use the aliases so you're aware of what you're really doing. So this is logging broker, so this logging broker mock.object. This is great. So that's what we have here. We basically built just the basic things that we're trying to do. In addition to all that, because we're behavior driven, we want to be able to test things based on random data. We want random data that we're able to test with. So we're not testing against a specific, scenario or a specific thing in our mind. We actually want to test against actual random data. So it hopefully will expose anything that we might be missing when we're trying to test our data. So I'm just going to use a library here. It's a really cool library. It's called Dynamics. I don't know if I already installed it. Dynamics is this pretty cool library that allows you to generate random data. It looks like I already it looks like I already installed it in the last session. So let's just leverage that Dynamics library. I'm going to go here and create a filler method, private static filler student. So I want a filler for a student model. I'm just going to go and say create student filler. And this student filler, let's go and say filler, new filler of a student. Right, and then our student model probably has date time, and filler doesn't really like date time offset. So we're just gonna, have it generate some random data in there. So filler doesn't play well with date time offset, so you have to set that up manually. So let's just go here and say filler.setup, and then under that, let's say on type date time offset, like this. Use date time offset .utc now. Right, something like that, right? So we're passing in some data, whatever the time is on the machine. We really don't care. We don't really run any validation on it. All the validations for the date time are happening on the server. And if you really want to see what that looks like, make sure you go to OSSS API project on GitHub so you can see what that looks like. So let's return the filler in here. And then on top of that, make sure your filler's at the bottom because nobody actually uses them outside of this class. So the more you use methods outside of your current class, that probably have the priority to be declared at the top. So private static student, and then create random student. So here's a random student for me. And this random student really doesn't require a scope. I'm just going to go ahead and say create student filler dot create. So this method here is basically going to create a random student for me. This method here is going to create a random student for me as a random input parameter to my work. All right, so that means I built this. So I built this. Let's go ahead and build a new file. And this file will basically be concerned about testing the logic of my service. So let's go here and say student service tests dot logic.cs. And this guy is going to be a public partial class, and its responsibility is to test the happy path. See how we're breaking out our tests in a way that would make it a lot easier for you to go and say, okay, do we have tests for exceptions? Do we have tests for validations? What's the logic for our tests that we're working with? So this is a partial class, so that means that this guy is also going to be partial. So we can leverage all of that good stuff that we were working on a second ago. And now we're going to start writing our first test, and our first test is going to be something as simple as fact public async task should register student async. So it's just the happy path. This is what I really expect it to do. There's no magic there, right? So here you go. Here's my task, and then let's break our test into 3 different pieces. These pieces is basically the part where you set up your test, the part where you actually run your test, and then the last part where you validate whether your actual logic actually matches your expected behavior. So let's just go ahead and do that. I'm going to say given. This is where you set up things. When you execute things, and then when you actually validate things. You'll see people that say assert, assign, arrange, assert, assign, something like that. It's the same idea, whatever you want to use. Given, when, then is a lot easier from my perspective because it's the same language I use to write user stories and describe particular behaviors. So an engineer could actually look at a user story in Jira or Azure DevOps or whatever the case may be and say, okay, as a student or as an administrator, when I want to enroll a student, I should be able to register that student in the database. Or when a student is coming new to the school, it should then be registered in the schooling system. So it's the same language, very close language for the engineers to look at and understand. All right, let's create a random student. So here's a student. Let's pull in the model. And let's say random student. And this random student will come from creating a random student right here. Right, so that's a random student. And then out of that random student, I'm going to define input student. So that's my input student that's coming in from a so out of random student, I'm creating input student. And you'll see how I'm using the exact same variable. I'm just giving it multiple different names, so it's a lot easier to read and understand. In fact, actually, when you look at the way how I'm defining your variables in here, it basically is telling you the story. So we're basically saying we created an input student out of a random student, and then in here, retrieved student, because you retrieve, you're basically pushing and retrieving. So in here is basically equivalent to the input student. And then here's another student where we say expected student equal retrieved student. So I basically told you the entire story just by describing my variables in here. As we're writing the code, you will see how this comes in very handy. So when I'm setting up my mocks, I could go here and say API broker mock.setup. And here's my broker. And my broker here, when I say post student async, then I want to pass in the input student, and I want it to return asynchronously the retrieved student. Look, retrieved student like this. See the language? If you describe this as student and you say post student, student, and retrieve student, it just doesn't sound right to me. You know, it sounds like a weird code to me. You know, when you name your variables properly like this, so when you use them, they make sense. You know, that's much more. A lot of people say it's just one variable, man. Just create the one variable. I'm really like, nope, nope, that's not really the case. You know, it's, yes, it is one variable with the same reference and the same name, similarly the same value, but not the same name. I'm using that name to make my code a little bit more readable. Okay, so this is the setup of my mock. So basically what I'm saying is that when this API broker mock, when this dependency is called by post student async, I should be able to retrieve that particular student as soon as I send in that particular input parameter. So that's pretty much my setup. It's very simple. I'm basically saying when that student is not in good shape, just go ahead and do that. All right, so let's see what comes after that. Then what's going to come after that is basically us saying here simply, I'm going to actually run the application. So here student, then this is my actual student then. And if I go and say await this dot service dot register student async with the input student like this looks a little bit too long. Let's break it apart a little bit like this. Then basically register student async. You're passing in an input student, right? Then my actual student should technically be equivalent to the retrieved student, which is basically equivalent to expected student. Because I'm using fluent assertions, I can just very simply go and say actual student should be equivalent to expected student. See how the language, see how the flow of the language is going? It's like you're writing musical notes, right? You're basically, as you're writing your code, it's actually making sense as you go. So okay, so this is actual student, and then let's go ahead and say, let's verify that this guy was actually called only once, right? So let's go here and say this dot API broker verify, right? Broker dot submit, sorry, post student async with that input student was only called just one time. So that's the first verification. Second verification, let's make sure that no other dependencies were called in our system. So here's mock API broker verify no other calls. So that makes sure that anyone who tries to add code in your system regarding that dependency, they don't get away with it. They don't get away with it, because if they tried, you know, this guy is gonna throw an exception and say this is not working. Some other dependency or this same dependency is being called more than once or is being called for other things. Alright, so this is this API broker mock. Let's go ahead and say also my logging broker mock verify no other calls, and since we didn't call it at all, we're just making sure that no other dependencies are being called in my method. So let's take a look at this. We did the setup, and here is the execution, and in here I basically did the verification. Just as straightforward as they can be. If you go and say Control RT like this, it will basically run the test for you. And we should have a failing test. Here we go. And failing test. So this failing test here will say this method or operation is not implemented. That means that we're actually calling the right method and we tried to implement it, you know, and we tried to run it and it didn't match our expectations. Let's go ahead and commit that part. This is part of calling your software development process pure, meaning that every single step Every single quantifiable step that we're taking is documented through commits, right? They call them purest approach, pure coding. You know, there's some articles about that that I'm going to put in the description area. Let's just go ahead with that and say, should register student async has failed. So this is the failing part of my student async. Now let's go implement it. Let's go make it pass. So let's go into here. If you do right click, go to implementation, and here's my implementation. Let's just go ahead and do that. We're going to go here and say, return await this dot API broker dot post student async with the student. This guy will basically do that. I need an asynchronous in here. Some people say, you know, you don't have to asynchronize, you don't have to resolve. You don't have to resolve unless you don't unless you need it. That's fine. It's just a preference. I don't think it has any performance, you know, amplifications. I am okay with the people that do it this way, but as we progress, I'm going to show you why that approach is not exactly the way I want to take. So let me just clean up some things in here. As you can see, the cleaning up of your coding process is an ongoing process. You're always cleaning up, you're always making sure things look right. In a situation like this, I can probably make this a one-liner like that. You know, take advantage of these things. This is some of the powers of C#8 programming language. As long as your line of code is not over 120 characters, meaning that it fits within a laptop screen so people don't have to keep scrolling right and left, then you should be in good shape. So, all right, so I have this guy running. Now I could just go here and say run my tests, and technically my test should be passing. Let's see if that's the case. Register student async, and this guy passed because we have done the right thing. This is test driven. I've written a test, the test failed, went from red to green, and then I'm refactoring. So right click in here and let's just commit this guy as passing. Now let me stop you here for a second. Let me talk to you a little bit about something. A lot of people will say, okay, that's it. You know, we wrote a passing test. The test is passing. We're in good shape. We don't have to do anything else. Building the happy path, anyone could actually do that. Happy path, you could teach that to anyone. Anyone can build the happy path for you. What actually distinguishes an engineer from someone who's just a coder, you know, someone who's just a programmer without any engineering mindset, someone that doesn't see the full process and can imagine all the possibilities, is this upcoming piece of this video. You know, being able to handle all the possible scenarios that may go wrong with your system, right? So maybe the student is null that's coming in. What are you going to do about that? Are you really going to send the object all the way to the API and wait for the API to come back for you and tell you, oh, it's broken? That doesn't make sense. Maybe the student ID is not in good shape. Maybe the structure of the student is not in good shape. Maybe the configurations are broken. There are so many cases. This is where engineering actually lives. Engineering doesn't live really in the happy path. Anyone could do that, you know. Engineering lives in the area where the edge cases may occur. Like we say, Murphy's law. Whatever can go wrong will go wrong. So let's know what can go wrong, and let's defensively program against it. So in this section here, I'm going to actually be talking to you about this piece specifically. Let's start with the cases where things are not going as expected. So I'm just going to go here and create a new file in my test project. And this file, I'm going to call it student service tests dot validations. Validations as in all the possible things that could be structurally wrong with my student object. So I'm just going to say public partial because it's part of the big thing, and then I'm going to add in copyright for the good-hearted engineers of the world. And then I'm going to write a new test in here. And this new test is going to be basically mainly focused on all the edge cases, the things that can go wrong with the request that I'm working with. So let's go ahead and work with that. In here, I'm going to go and say fact. And I'm going to go here and say public async task should throw validation exception on register if student is null, and log it async. So this is one method that I have, and this method is basically telling you three things, three very important things. The first thing here, it's telling you what should happen. This part is telling you what should happen. A validation exception should be thrown. And then where it should happen. And then when it should happen and what should accomplish on it. Meaning that, so if I break this apart for you, I would tell you every test name has a standard. And the test name standard is to tell me what, where, and when. So my what should happen is that a validation exception should be thrown. So that's the what. Where is that? Which method will that be happening on registration, on student registration? So on student registration, we basically go and say when this happens, we want to be able to, in this location, when this happens, this is what we're going to be doing. And then the last one is when. When meaning what event need to occur within that register so the what could happen, which is the validation exception will be thrown. When student is null. And then log it async, just any additional action that we need to do. How are we going to build that? Let's go ahead and do that. So here's a given when then, and I'm going to go here and say student invalid student, because this student is null, it's invalid, right? And then my expectation is that I will never be able to call my API. I'm not going to let my service actually call the API when something like that happens, right? So I'm just going to go here and say var null student exception. Now focus with me here for a second. There is when we throw an exception, any service that you will ever build can throw one of three exceptions. It's either a validation exception because of some validation rules that have been violated. It's either a dependency exception because a dependency that you're trying to call and the dependency is not available, so it breaks apart. Or a service exception, meaning everything else that could possibly happen, a null exception, a memory leakage, bad library, infrastructure, whatever the case may be when it comes to service exceptions. In this case here, we're targeting a validation exception. Under each one of these categories, there are smaller exceptions, inner exceptions that describe exactly what happened. In our case here, it will be null student exception. So the student that we're trying to pass in is null, but I really don't have that modeled yet. So let's go into the models in here under the students and create a new folder. And this folder will be called exceptions. I need a couple of those. For this test, I need the first one, which is null student exception. Let's build that together. And this null student exception basically is me going and saying inherit from exception, and in your CTOR, take the base and say student is null, or something like that. Null student error occurred is better. Null student error occurred. I think I'm typing that right. We'll see. So here's my null student exception that's happening in here. Null student exception or error has occurred. Okay, that's the first error. What about the second one? The second one is the parent exception that needs to contain that exception to propagate an error to determine what needs to happen with the next service. So let's go here and build student validation exception. And then this student validation exception, I'm saying inherit from exception. And in here, I'm taking in an inner exception. In our case here, in this particular case, it would be the null student exception. And under that, in the base area, I'm just going to go and say student validation error occurred. Try again, or please try again. And then we pass in the inner exception. You can say contact support. You can say try again. It really all depends on whether you want the user to fix their error or you want to fix the error for the user. Is it internal or external? This is a little bit of an advanced topic that I didn't really have the chance to talk about yet, but here we are. Okay, so we have that stuff. That's great. Let's go ahead back to our tests here. And I'm going to go ahead in here and say, let's add the null student exception. And I expect within that null student exception, since this is a one-liner, let's keep it this way. I'm going to say expected student validation exception. New student validation exception. And I'm going to pass in that null student exception in here. So I am basically here saying my expectation is that my service is going to throw a student validation exception with an inner exception that says null student exception. Null student exception. Which means that my API is not going to be called, nothing else is going to be called, so I'm not going to set up my brokers in here. So the same thing that I did here is not going to happen, except that I'm going to validate that this particular method was never called. This particular post student async method with any student was never called. So let's go back to our test here and write some more. So here's a value task. Notice that there's no actual and expected student, none of that stuff. I'm actually picking up the entire process when we're registering the student. I'm going to assert it. I'm going to examine it to see if it's actually throwing the exception that it's supposed to. So this will be, instead of actual student, it will be submit student task, which is, see, I'm not awaiting. I'm just saying service dot submit student async with this invalid student in there. So I'm passing in this invalid student in there, in that student model. Great. Great. Now let's go here and pick up this guy here and say await assert. Now I'm going to execute that task. So throws async. So I'm expecting this guy to throw a student validation exception. And this student validation exception will have submit student task as task, because this guy doesn't really take value task, it takes a task. So this task, I'm going to run it inside that throws async to validate that it actually threw the exception and doesn't halt my test, because I still have more things that I want to validate after that. So in here, I'm going to go here and say, okay, so that means my API broker, sorry, before that, that means that my logging broker mock, I want to verify that my broker mock in here have logged that error. And this is really important. This piece here, I want you to focus with me on that part. This basically here means that I don't want the exception to be thrown and that's it. I also want to be aware as an engineer through the logging and alerting and all that kind of stuff that an error has occurred and I need to take advantage of it. In order for that to happen, I need to go and say, if you pass in that exception in here directly, it's not going to work with you. Why? Because it has a different reference. You're creating here the expected student validation exception, but on the service layer, it's actually creating its own validation exception. So that's not going to fly. Right? That's not going to fly. So let's go here and say, instead of that, let's go say, let's compare by the value instead of the reference. And in here, I'm saying it is, and then same exception as, look, expected student validation exception. I expect that to be called once. So what is this thing that I just did? Let's break that apart a little bit so it's easy to read. I'm basically saying the exception that will be thrown inside that logging error will be the same as this one. The same as meaning that this exception is the same content as the exception that will actually be thrown, but they both have completely different references in memory. But they are exactly the same when it comes to content. Same exception as is not something that you get out of the box. What you really want to do here is that you want to go here and say private expression. Inside that expression, there's a little func in here. And inside that func, we'll basically saying, I'm giving you an exception, and I expect a boolean. And this is same exception as, and I'm passing in an exception in here. And that exception will basically say, let's call this expected exception. Expected exception like this. Right? So this is same exception as. Let's bring in the system link expressions, which is something I really admire. It's pretty cool. And then under that, I'm going to go and say return actual exception. Where is that actual exception coming from? It's coming from this guy, because this is the func that you're describing, basically. Actual exception, then actual exception dot message should be equivalent to expected exception dot message. And tabs here are not right. There you go. And actual exception dot inner exception dot message, because that's the one I care about, should equal expected exception dot inner exception dot message. So I'm validating that the inner exception message is the same, because the message is what's actually gonna be looking at. You know, what really happened. So we want to validate that the actual exception message is the same and that the inner exception message is the same. If you're reporting about a null student, then whatever your exception is called, that's really all I care about. If we go back to our validation here, you'll notice that this guy is happy. This is a little bit complex topic, but it's really making your code a lot easier to read. We're basically saying log error with something that it is the same exception as your expected exception that you have in here. All right, so let's go ahead in here and let's go and say, additionally, this.API broker mock verify that this broker was never called during the process, during this operation. So post student async with it is any student. Don't care what student it is. Don't create a default one and post it. You know, this was never called. This was never ever called. So this is basically me verifying that, you know, this student, the post student API was never called in that case. All right, great. That's fantastic. So let's go after that and then do the same thing with our mocks, verify no other calls. And let's do this with our logging mock, verify no other calls. It's all good and dandy. So if you look at my test here, I basically said I'm going to pass in a null student. I expect that a null student exception will happen. It will be encapsulated in a validation exception. And then when I run my system, assert that this student validation exception has occurred, and then log the error that happened, log that exception, and then make sure you verify that no other calls has been made. All right, let's run this guy. And this guy is failing. And this guy is failing because it says I expected you to throw a student validation exception, but in reality, what actually came back is that no exception was thrown at all. Great, that's a failing test. Let's go here and do a commit. And in my commit, I'm basically going to go and say, here is my test. I'm going to say fail. This is a failing test. All right. So let's go ahead and make this pass. So let's go into the register student async like this. And instead of doing that, I'm going to add a couple of more partial classes that will take care of that for me. Usually people include the try catch and the validation and everything in the exact same method, which is not single responsibility and very hard to read, right? We're going to break that apart a little bit. We're going to walk through that and break it apart a little bit. So let's just go ahead in here and create a new partial class. It's going to have the same name, so student service, and then dot validations dot cs. And this guy specifically is going to contain the methods. So let's make this partial. It's going to contain the methods that validate my student object. So in here, I'm going to go and say private void validate student. And it takes in a student object, student, like this. Like this. And then I'm going to go and say if student is null, you can do that. You don't have to say equal null or whatever the case may be. Then throw new null student exception. Obviously down the road, we're going to break that apart even further. You'll see. So let me clean that up. Let's add I made my Visual Studio full screen. Let's add in the copyrights, and then let's call that validation method in here. So we can't use that fat arrow function anymore. We have to do it this way. We have to say return, and then in here I'm going to go and say validate student, and I'm going to say pass that student in here. See how partial classes are very, very powerful in the sense that, you know, they allow you to keep your code clean. Like if you're looking at logic, you're looking at logic. If you really don't care to look at how the student is being validated and you just want to keep focused on what it takes to communicate with an outside world, then you don't have to see that in here. You can think of this top layer class at the top here as your index of your book. It has the high level, you know, introduction, what it's doing, and then if you want to get into the nitty-gritty of things, there are those partial classes that you need to take care of. But that's not enough, because basically this student, validate student, is only throwing null student exception. That's not enough, right? That's not enough. Why is that not enough? Because we're actually wrapping that inside of a student validation exception. So we're going to go another layer, and we need to log errors and do stuff like that. So let's create another partial class, and this new partial class is going to be responsible for only handling the exceptions. Only handling exceptions. So let's go in here and say student service dot exceptions dot cs, like this. I'm going to go here and add in the banner and then say this is partial, and then I'm going to create a little delegate that represents the method that I'm trying to represent. So I'm going to go here and say private delegate and then value task student, and then returning student function. I don't really care what the function is doing. This is just a delegate that represents any function that returns a value task of a student. And then I'm going to do a little magic in here, which I'm going to go and say private async value task student, which is exactly the same thing that you're returning. So this student, like this. And then I'm going to call this try catch. And this guy encapsulates all the different exceptions that I want to handle in my work. A lot of people say, why don't you just handle the exception from the top layer? To these people, I basically say, if you do that, then you actually have dependency, like your component is not self-sufficient. Your student service is not sufficient. If I take it out and make it its own microservice, I'm going to have to pull other things from everywhere because it has all these different dependencies. But people have their own different thoughts about, you know, tackling different things. And as you go through this practice, you'll understand how things are done, you know, at least how I build things personally. Okay, so this is a function, returning student function, right? So what gets passed into that try catch method, a method that takes method basically. And inside of that, I'm going to go and do that try catch, and the first thing I'm going to handle is the null student exception. And I'm going to wrap that up. Look now what I'm going to do. I'm going to go here and say throw, create, and log validation exception. Where's this validation exception coming from? I'm going to tell you in a second. So just one small method that says create and log validation exception. In here, I'm going to go and say return await returning student function. This is very, very unique pattern into abstracting away the exceptions. I've talked about this in detail in a special video called handling exception noise in C#. Please go back. I'll put the link. Take a look at it and learn from it. All right, this is great. Let's go ahead and just do exactly that. Let's go here and say create this method here. And this method should return student validation exception. And it takes in literally any exception out there because we're going to use it multiple times. And in here, we're going to go and create var student validation exception equal new student, new student validation exception, like this. And inside that guy, there will be null student exception, like this. Null student exception. Right? And then inside of this guy, I'm going to go and say this.logging broker, which we have defined originally in our partial class, the top layer, as an a dependency. I'm going to log error, and I'm going to pass in this student validation exception. This student, see what happened here. This student validation exception has taken in this null student exception as an inner exception. And now it's passing this guy in. The last thing I want to do is just return that student validation exception so I can throw it. So student validation exception, I'm returning this guy so it can take that in and then throw it out. The last thing I want to do, I want to make sure that this function is used in here because my tests are still failing. I'm still not doing everything I should be. I validated, I created a null student exception, but I haven't really thrown that exception yet, right? So it's still failing. The last thing you want to go here, you want to go here into your method and say, put a fat arrow on this one and go back here and say try catch. Wrap that entire statement that you have in an anonymous method. And let's take the async from here. And now you have this register student async. See how I wrapped my method into a try catch without saying try catch, without your usual try catch, your traditional classic try catch. I'm basically going here, I'm saying whatever happens in here, handle it in this method here. So the method that we have is actually being called in here, and that's the try catch block. And we're going to add more blocks to this, like you're going to see in a little bit. Like as we go, we're adding more and more blocks to this. So let's just go back here and say, okay, does that make my test pass? I don't know. Let's run them all and see what happens. Here we go. There you go. So the test has passed. So that means I am successfully able to write clean code, very abstract, and my code is basically handling any exceptions that may happen from that student object coming in. All right, so if that's the case, then let's just go ahead and submit that passing test in here. So this guy now, oh, not this one. This is should register student async. Let's go into the validations one, and let's pick up this one, and let's go and commit this guy. And let's say this guy has passed. Right? So that's one part, right? So this is one step, right? But the student model has a lot more to it than just that. Like a student model has a user ID, and this guy is not supposed to be null. It has an identity number. It has a first name. It has a middle name. It has a last name. It has a date of birth. It has a gender, and has all these different information that we want to make sure that that information is in good shape. So the next video, we're going to work on finalizing the validation piece for the student. And then we're going to talk a little bit about how to handle API exceptions that are coming from the API. So APIs throws all different kinds of exceptions. Like API will throw a 404 not found. And then how do you distinguish between a 404 that the entity is not found versus 404 and that the URL is not found? And then APIs will throw 500 exception. APIs will throw unauthorized exception. APIs will throw internal server error exception. How would your Blazor application properly handle all these exceptions that are coming from your API, and how to log the right information? And then eventually, a couple of videos down the road, I will show you what kind of message you want to communicate to your end user. I hope this was useful. I hope you enjoyed the session. Obviously, you know, the stuff that I was just talking about is actually can be applied to literally a mobile API or a Blazor application. So that's understandable, you know, but it's definitely a part of your Blazor client work. If you're actually building a pipeline as we spoke, it's definitely part of your Blazor client work. So the next session will finalize the validation of these services. And then we will move on to the view service, where we start talking about the mapping of data, what really matters versus what doesn't matter, and stuff like that. And then the last thing we're going to do is basically to go and say, okay, out of all of these validations and all that, let's start building an actual Blazor client and communicate the message downstream to the API to see how things work end to end. I thank you so much for watching this, and you know, please don't forget to like and subscribe. I'll see you in another video. Thank you so much for watching. Have a good day.